Welcome to The Explainer. Today we're going to do something cool. We're going to take a math concept you probably haven't thought about since, middle school? And we're going to show you how it's actually a super powerful tool for planning, pretty much anything. We're talking about limits, boundaries, and how you can make really smart decisions when you're working within them.
So to get started, let's not even touch the numbers yet. Let's go way back. I want to start with an ancient story, one that's all about managing resources. You might have heard of it. It's about Joseph in Egypt, who had this massive job of planning for a famine by storing up grain when times were good.
Now, this story wasn't just about food, right? The real heart of it is this challenge that we all face every single day. How do you work within boundaries? How do you plan for the future when you know for a fact that your resources, your time, your money, your space, they aren't infinite?
And that question? That's what brings us to a really powerful mathematical idea, an idea that helps us solve this exact problem. It's basically a special language that lets us talk about limits with total precision so we can make the absolute best choices we can.
Okay, before we get to the actual math, let's just take a second to really frame the problem. Because this is a dilemma it's as old as civilization itself.
Every single project, I don't care if it's storing food in ancient Egypt or designing an app on your phone today, has one thing in common: constraints. You've always got them. Maybe it's a budget for a new kitchen, the physical space you have for a garden, or the amount of material you can use for a project. We always have to work within limits. So the big question is, how do we talk about these constraints with any kind of precision? Well, we use the language of math, and trust me, it's way simpler and a lot more powerful than you might think.
The tool we use is called an inequality. Now think about it. An equation is like saying the answer is 5. It's one specific thing. But an inequality, that's different. It doesn't give you one exact answer. It gives you a whole range of possibilities. It's like it draws a line in the sand and says, anything on this side is good to go. It creates a zone of acceptable outcomes.
And that right there, that's the key difference. Look at this. An equation is totally rigid. It's a strict rule. X equals 10 means the width has to be exactly 10, no wiggle room. But an inequality, that creates a flexible boundary. X is less than or equal to 10 means the width can be 10, sure, but it can also be 9 or 8.7 or 5.5, just as long as it's not, say, 11. It literally gives you freedom within a limit.
So here's the big idea. This isn't just some abstract math concept, okay? It's a super practical tool. It's how we translate real-world rules, like the garden can't be wider than this, or the box can't hold more than that, into a language we can actually use to solve problems.
All right, enough theory. Let's actually put this thing into practice with a few real-world design challenges. This is where it all starts to click and, really come to life.
Okay, example 1. Let's start really simple. I want you to just imagine you're out in your backyard. You've got the tape measure out, and you're planning where to put a new garden fence.
So you're looking at the space you've got to work with, maybe between the side of your house and the sidewalk, and you realize, okay, there's a hard limit here. I can't go past this point. Boom. That's your first rule, your first constraint.
And check this out. This is how we write that rule down in the language of math. If we just call the width x, then all we have to say is x is less than or equal to 10. That's it. It's a super simple, perfectly clear instruction for our plan.
All right, you got that? Let's ramp it up just a little bit. Example 2. This time, our constraint isn't just about a simple length, it's about the area of a shape. So we have a trapezoid, and we know its area can be no more than 40 square units. Our job is to figure out one of its other dimensions. So how do we figure out the maximum possible height? Easy. We just start with the standard formula for the area of a trapezoid. Then, as you can see, we just plug in the numbers we know. Our limit is 40 for the area, so we set that up, we pop in the bases, 8 and 4, and then we just solve for our unknown, h. And what do we get? The result tells us our height has a firm boundary. It can't be more than 6.67 units.
Okay, time for a little twist. Example 3. So far we've been talking about maximums, no more than this. But what if the rule is a minimum? What if it's a requirement you absolutely have to meet or even exceed? Well, it's actually super simple. The inequality symbol just flips around. Instead of using less than or equal to, we use greater than or equal to. So if the perimeter P has to be at least 30, we write P is greater than or equal to 30. Done.
You could imagine this being a rule for, say, a dog run, to make sure the pup has enough space to get some exercise.
Okay, you've seen how this tool works. Now it's your turn to be the planner. I'm going to throw a few quick challenges at you. As they pop up on the screen, just see if you can figure out the inequality in your head before we move on. All right, first one, super simple fencing problem. You've got a clear maximum limit. You can use no more than 20 units of fencing. So, what's the inequality for the length, which we'll call x?
Okay, next up. A square's perimeter is 12 units or less. The question is, what's the maximum possible side length? Now remember, the key here is that it's a square. All 4 sides are equal. How does that change things?
And for the last one, let's go 3D. We've got a box. Its volume can be no more than 100 cubic units. We know 2 of the sides are 5 and 2. So, let's use that same logic we've been practicing. What's the maximum length for that third side, x?
All right, how'd you do? Here are the solutions. You can see for each one, a really simple inequality gives us our answer. For that square, if the perimeter is 12 or less, then each side has to be 3 or less. For the box, that third side can't be more than 10. See? It's the same logical process every single time. You're just defining a clear boundary for your design.
And just like that, we've kind of come full circle. We started with that ancient story of Joseph, who used his wisdom and intuition to plan within the limits he was given. And what we've seen is that we can now tackle those same kinds of problems with simple but really powerful mathematics. It's the exact same fundamental skill.
So here's the real takeaway I want you to leave with. Inequalities, they're not just for math class. They're a way of seeing and structuring the world around you. Think about it. What's the limit in your own world right now? A budget, a schedule, a project at work. What's a constraint that you could actually describe with a simple inequality? Because once you can name your limits, once you give them a language, that's the first step to making the absolute most of everything you have to work with.